So far in the examples that we've completed, the roots have been the same, or the index, or the bases have been the same, and so it's been really easy to reduce them. Now we're going to start getting into examples where the index or the bases are not the same, and so that makes it a little bit more complicated to reduce. And we're just going to practice those examples. Starting off with number 5, we have the fourth root of 27 divided by the square root of 3. So there's a couple things you want to notice. First, notice that the index is different for both. Here we have a 4, and here we technically have a 2. So those are different exponents. And then also we have a 27 as one base and a 3 as the other. And so we have to, if they're different, try to make them the same, because remember in our exponent rules, if the bases are the same, we can do a lot with our exponents. And so when you look at your bases, you always want to see if you can make them match first, and then you can always try to reduce as much as possible. And I'm going to go ahead and start with that. So I'm going to go ahead and first write my problem in exponential form. So 27 to the 1/4 divided by 3 to the 1/2. And then I want to think about, can I change 27 so that it's written with a base of 3? Well, you have to think about 3 to what power gets you 27? Well, that's to the 3rd. So I'm going to rewrite my 27 as a 3 to the 3rd, all to the 1/4 power. So this is the same thing. I just took 27 and I wrote it with exponents in it. Okay, so 3 to the 3rd is 27, and then I'm going to keep the denominator the same. Now I can use some exponent rules. I've got a power to a power on the numerator, so when I have a power to a power, I can multiply. So 3 times 1/4 is 3/4. That's going to get me 3 to the 3/4 over 3 to the 1/2. And because my bases are matching now, I can use my exponent rules for division, and that says that when I'm dividing the same bases, I can subtract my exponents. So I'm going to put here, subtract the exponents, right? And so if I do that, I'd have 3/4 minus 1/2. When I subtract those, that's going to get me 1/4. And so I can rewrite my answer with the same base, but to the 1/4 power. Now, one thing I would always make a rule for you is that if it started in radical form, make sure you write your final answer in radical form. So I'm going to change the exponential form to the 4th root of 3, and that would be my final answer, and I'm done. Okay, so I had different roots, different index numbers, but because I changed them to exponential form and then changed my bases so that they matched, I was able to cancel and reduce some things down into one nice number, and then I was finished. Okay? Same concept applies for number 6. So let's go ahead and do that. I'm going to change them first to the exponential form because my index and my bases do not match, and that's going to get me 81 to the 1/8, over 6, or 3 to the 1/6, Now, can I make 81 have a base of 3? Yes, you can. 3 to the 4th is 81, and that's all going to be to the 1/8 power over 3 to the 1/6. And again, multiply my powers here, so I'm going to be left with 3 to the 4 times 1/8 is the same as 1/2 over 3 to the 1/6. And then just like number 5, my bases match. So I'm going to leave my base the same and then subtract the exponents. 1/2 minus 1/6, that's the same as saying 3/6 minus 1/6, and that gets us 2/6. And you can reduce that down to 1/3. So 3 to the 1/3 power. And because I started in radical form, remember, change it to radical form here. So that would be the cube root of 3, and you would be done. Okay, so change it to exponential form, see if you can reduce it, and then at the end make sure you switch back to its original form. These are our last 2 examples of this section. Obviously, there's lots of different examples I could give you, so if you need more past these last 2, please ask and I will go through a couple with you, anything to make sure you're comfortable with our exponent rules. In these 2 examples, we don't have any fractions, but we've got different size index values and as well as whole numbers and variables underneath. So very similar to the last section with reducing, you just want to make sure you reduce all the way. In this case, we're going to start by taking the cube root of 64 first. Remember, you always do each part individually. So if I start with the cube root of 64, unfortunately, you can't take the cube root of 64 as is. Remember, this is the same as 64 to the 1/3. However, remember, we want to try to get our index to cancel out. So you want to think about, can you take something to the 3rd power to get you 64? Well, in this case, you can. 4 to the 3rd is the same as 64, and I have it to the 1/3 power. So because I was able to change my base, it allowed me to cancel out my exponents much nicer. So 3 and 1/3 cancel out, and that's just going to leave me with a 4. Okay, so we're going to have a 4 in our final answer. And then I'm going to do the same thing, but I'm going to do it with my variable this time. So I'm going to change this to the cube root of x to the 6th. And remember, when you're dealing with exponents, we just divide. So 6 divided by 3 is 2. And remember, that means we're going to have an x squared on the outside. So this one actually reduced really nicely because all my radicals went away, and then I was just left with the answer for x squared. Okay. Please be careful, especially with the numbers. You might have to change your base in order for things to cancel. That's very important to make sure you remember that. All right, let's try this last example together. We've got the 6th root of 81g cubed. Let's start with the 81 first. That's going to give us the 6th root of 81, and I'm going to try to reduce it. Remember, you want to try to get the index here to cancel completely like it did over here, or to at least reduce. Unfortunately, there's nothing to the 6th power that's going to get you 81. So we're not going to be able to use an exponent of 6 like we did with here with the 3. However, we can rewrite 81 with an exponent. We could rewrite 81 as 3 to the 4th. That's the same thing as 81. And we're going to change this to exponential form. So 81 to the 6th root of 81 is the same as 3 to the 4th, all to the 1/6 power. By changing it to my exponential form, I can deal with my exponents here and reduce them, and then I can move on to the letters. So if I take 4 times 1/6, 4 times 1/6 is the same as 4/6, which reduces to 2/3. So I could rewrite this as 3 to the 2/3. And if it helps to change back to your exponential form, or to your radical form, sorry, this would give us the cube root of 3 squared. Well, what is 3 squared? That's 9. So we'd have the cube root of 9, which you cannot break down any further. So there's our first part of our answer, is the cube root of 9. Okay. And then we're going to take the 6th root of g cubed. So I'm going to do that in red. So the 6th root of g cubed. Remember, if you can't reduce it right away, try changing it into its exponential form. So if I change this, I'm going to get g to the 3rd all to the 1/6 power. So if I multiply my exponents together, that gets me g to the 1/2. And you can't break that any further, but we do know that g to the 1/2 is the same as the square root of g. So I'm just going to have times the square root of g. And this would be the reduced answer. Notice that at the beginning, they were both the 6th root, but because I've reduced each part individually, I have a cube root and a square root, and that's okay. Sometimes they're going to reduce more in one part of the problem than in the other, and if they end up with different roots, just write them side by side as 2 separate parts. So that we'd have the cube root of 9 times the square root of g, and that would be your final answer. So anytime you deal with these where you've got multiple parts underneath the radical, make sure you deal with each part individually and reduce them as much as possible, and then write your final answer all together as one. Okay, if you have any questions on the reducing or changing from radical form to exponent form, please make sure you ask me, and if you need some extra practice problems, I could gladly get those for you. Just let me know. That's it for today. Thanks for listening.